Good morning. Welcome back to our Level 6 Math. Today, we're going to look at Lesson 65 on prime factorization. Now, this is a three-parter because we're going to look at division by primes and factor trees. It's actually one of the more difficult lessons we've had for a while. So hang in with me today. There's a lot that we're going to cover. The good news is they're all connected, and once it clicks for one thing, it's going to click for all of it. So this really isn't really challenging. It's just a lot of new stuff, okay? So let's start by just looking at the difference between prime and composites. Any number, a whole number greater than 1 is either prime or composite. A prime has only two factors, 1 and itself, right? A composite number has more than two factors. So as we look back at some of these numbers, the numbers 2, 3, 5, and 7 are prime numbers because no other two numbers go into it. It's just 1 times that number gives us that. The numbers 2, 4, 6, 8, and really any even number is going to be a composite number. Every even number that is except for 2. And then composite numbers, all composite numbers can be formed by multiplying prime numbers together. So we'll look here at our composite numbers, 4, 6, 8, and 9, and we get them by multiplying a bunch of different prime numbers. So 2 times 2 is 4, 2 times 3, those are both prime, equals 6. 2, again, is a prime number. 2 times 2 times 2 equals 8. And 3 times 3 equals 9. So any composite number is going to be a bunch of prime numbers multiplied together. We see that here again. When we write a composite number as a product of its prime numbers, we have prime factorization. So this is the prime factorization. And today we're going to practice taking a composite number and finding all the prime factors that go into that number. So we're going to look at two different ways to do that. Okay? We break it into its different prime numbers. So we're going to start by looking at, actually we're going to stack first and then we're going to do factor trees. So we're going to do division by primes and use a method called stacking, and then we're also going to look at factor trees. Both of these, here's the good news, both of these methods are really easy. So if we're thinking about what are all the prime factors that go into a composite number, it's a really easy way to figure it out. You are probably going to have to write it out though. A lot of these would be really hard to do using mental math because you're going to be juggling a lot of numbers. And so you'll use mental math to solve for your factor trees or your stacking, but you'll want to write it out. All right, so first let's look at this one. To factor a number using division by primes, we write the number in a division box, dividing by the smallest prime number, which will usually be 2. Well, it'll always be 2 if it's an even number, because the smallest prime number or prime factor of any even number will be 2. If it's an odd number, we just have to think using mental math, what is the smallest prime number that will go into that number? And it might be 3, it might be 5, might be 7, might be 9, but it'll likely be, 3 or 5 because those are lower numbers. So here we look at 60. So 60 is the number we're starting, and we're going to try to find all the prime factors. So we start by dividing by 2 because 60 is even. So 60 divided by 2 is 30. Now here's the cool stack. Now we need to find the prime factors of 30, and we can do the same thing. 30 is still even, so let's divide that by 2. And we do that by stacking here. So we start with 2 goes into 60 30 times. 30 divided by 2 is 15. Now we can keep doing it. What's the lowest prime number that goes into 15? Now it's not even anymore, so it's going to be 3, right? 3 times 5, so we'll put 3 times 5, it'll look like this. 3 times 5 is 15. Now we have our stack. 5 is a prime number, so we know we're done. So your last number here is going to be prime. And then we have all our factors, so we can see they went one more step to get, 5 divided by 5 equals 1 to go into the smallest ones. But we're going to see all our prime factors in this one or in this one. It's going to be 2, 2, 3, and 5. We don't need to worry about 1. All right, so by dividing the prime numbers, we found the prime factorization. 2 times 3 times 5, that equals 60. We can try it. Let's see if it equals 60. 2 times 2 is 4. 4 times 3 is 12. 12 times 5 is 60. If we did this in a different order, we could still find it. 5 times 3 is 15. 15 times 2 is 30. 30 times 2 is 60. So we can always check our work with these. All right, so let's use division by primes to find 36. So we're going to start with 36. Is that an even number? Yep, so we're going to divide by 2. 36 divided by 2 is 18. 18 divided by 2 is 9. 9, now it's not even anymore, so we'll take the smallest number, 3. 9 divided by 3 is 3. 3 divided by 3 is 1. Now we have our prime factors, 2, 2, 3, and 3. That's awesome. Woohoo! All right. It says some people prefer to divide only until the quotient is a prime number. That's me, so I don't do this last step. 3 divided by 3 is 1. It really doesn't matter if you want to go all the way or not. Just remember when we put our prime factors out, we don't need to include the 1. That's the important thing. All right, now we get to do factor trees. This is cool because it's just a different way, and a lot of students I found prefer the factor trees just because it's more visual, and it's actually kind of fun just to make the tree. So we start with 60, and we're going to think of any two numbers that make 60. So any two whole numbers that make 60. So we could do 6 times 10, we could do 12 times 5, we could do 15 times 2, or not 15 times 2, 15 times 4, or 30 times 2. Any of those go into 60, but probably the easiest ones, the ones that came first to mind for you, were 6 and 10. So we just take those branches, 6 times 10 equals 60. Now, are these prime numbers? Nope. So we have to make some more branches. So we'll take the 6 and the 10, what goes into 6? 2 times 3, of course. So we have 2 and 3, and those are prime, so we're done with that branch. Over here with 10, what goes into 10? 2 times 5, and those are prime numbers. So now we have all of our prime factorization. 2, 3, 2, and 5. We can check our work by multiplying it. 5 times 2 is 10, 10 times 3 is 30, 30 times 2 is 60. It checks out. The circle numbers at the bottom are all prime numbers, and those are our prime factorization. It's kind of fun. All right, let's try one more. Use a factor tree to find the prime factorization of 60. So we already know the prime factors because we did this number earlier, but we're going to see it with a branch now, or with a factor tree. So it says using 4 and 15 as the first branches. You don't need to. That's just the way they do it on this example, but you can do anything. You can do your 6 and 10, whatever you want. So we're just seeing a different example here. With 4 and 15, we're going to find that we have the same prime numbers. It might just be in a different order. What goes into 4? 2 and 2. What goes into 15? 3 and 5. So we've got 2 and 2, 3 and 5, the same numbers we had before, just a different order. 2, 2, 3, 5. It doesn't matter the order because when you multiply them, you're going to have the same product. Okay? That's it. That's the lesson. It's a lot to go through for today, so if you're getting frustrated, just know that other people are frustrated too. This takes practice. It's going to take some work to get through it. But once it clicks, again, this is one of those ones that you're going to be glad that you learned how to do it because it's kind of cool, and you'll use it for other things later on. All right, good luck.